So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the fifth largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, Studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hype that story up, The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination, and they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system, but this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years. In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, Astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that?
All right, dear viewer, let's lay it out on the table. The case is cold, just like the rock we're looking for. It's that hypothetical planet again, a real slippery character, warping orbits from the shadows. I've been following its gravitational rap sheet for years. It has left a trail of math miscalculations and confused astronomers. But it can't hide forever. This solar system ain't that big. If it's there, we will find Planet Y. Yep, another day, another quest to solve the solar system's riddles. New research points to another hidden world. I have to say, we shouldn't dismiss these theories until they're disproven. Scientists these days are overloaded with a vast amount of data. Thankfully, they have supercomputers going through mountains of equations bound to give a headache to someone like me. But it's how these theories come to exist. At one point, even Neptune seemed like a far-fetched theory. When Uranus was discovered in 1781 by William Herschel, for decades, it looked like the solar system's final stop. But Uranus didn't quite follow the rules. Something was off. Either the laws were wrong or there was an invisible hand out there. Two math nerds, Adams in England and Leverrier in France, picked up the abacus, and there it was. Neptune appeared exactly where predicted. That's a cool point for math. That triumph inspired the next hunt. In the early 1900s, Percival Lowell became hooked on the Planet X theory. He was sure Uranus and Neptune were still wobbling funny, so he pictured a giant mystery world yanking their strings. His team hunted for years. And in 1930, Clyde Tombaugh found Pluto. Pluto is Planet X? Nope, not so fast. Pluto was too small, it didn't fit. The hype faded, and decades later, Voyager 2 showed that weird orbits made sense all along. Planet X, at least Lowell's version, had never existed. Then came Planet 9. In 2016, researchers noticed that distant Kuiper Belt objects weren't scattered randomly. Their orbits clustered strangely, as if something was tugging them into line. They proposed a super-Earth, 5 to 10 times Earth's mass, orbiting hundreds of AU away. Simulations made it look convincing, but no one has seen it yet. A later discovery, a dwarf planet called 2017 OF201, made things even weirder. Some say it weakens the case for Planet 9. Others say it's more evidence. For now, Planet 9 is still a maybe. However, latest research points to another possible candidate, for now called Planet Y. Unlike the others, it's thought to be smaller, closer in size to Earth or Mercury, and hiding just past the Kuiper Belt. Here's the big clue. Way past Neptune, some icy objects are all tilted, like a bunch of marbles moving to the same side while on a flat surface. That shouldn't happen. Gravity should have straightened them out ages ago. The simplest explanation? A hidden planet, quietly warping the outer solar system like a mischievous babysitter. Astronomers check those Kuiper Belt orbits against the solar system's invariable plane, basically the balance point of all the planets combined. If things were normal, the orbits should line up, but they don't. They're all slanted the same way, like a bunch of pencils dropped on the floor, and somehow every single one points toward the same corner. According to researchers, the odds of that happening by chance are only 2 to 4%. That's similar to flipping a coin 5 times in a row and it landing on the same side each time. Astrophysicists ran their fancy calculations and came up with the simplest explanation. You guessed it, another object with strong gravity. The math shows that a world somewhere between the size of Mercury and Earth, orbiting 100 to 200 AU from the Sun, could maintain that tilt. Not too big, not too small, not too far, just the right size and distance to warp the Kuiper Belt without throwing everything else into chaos. And here's where it gets fun. In theory, Planet Y could coexist with Planet 9. Planet 9 is supposed to pull icy orbits into clusters, kind of like a sheepdog rounding up sheep. Planet Y doesn't cluster anything. It tilts the whole playing field instead, which means if both turn out to be real, we might have 2 hidden planets shaping the edges of our solar system in different ways. So why haven't we seen this mysterious neighbor yet? Simple. It's faint. At 100 to 200 AU, sunlight is thousands of times weaker than here on Earth. A planet that far away could only reflect a tiny trickle of light. To our telescopes, it would look like a barely visible speck drifting across a crowded star field. Kind of like trying to spot a sleeping gray cat in a dark cellar with only faint moonlight coming through the window. It doesn't help that Planet Y would move at a snail's pace across the sky. Snap a photo one year and another a few months later, and it might not even look like it moved. Older sky surveys weren't designed to catch something that faint and slow. They're great for spotting fast-moving asteroids near Earth, but hopeless for a dim tortoise crawling at the edge of the solar system. But the hunt isn't over. Astronomers are putting their hopes on the Vera Rubin Observatory. This massive new telescope will take pictures of the night sky in unprecedented detail. If Planet Y is out there, Rubin could be the one to find it. And if it isn't, well, Rubin will give us the best proof yet that it doesn't exist. Who knows, maybe it spots something entirely different. But what if Planet Y is real? Where did it come from? Perhaps it's a leftover chunk from the solar system's wild early years. Billions of years ago, when Jupiter, Saturn, Uranus, and Neptune were still migrating, massive chunks of rock and ice were flung around like cosmic bumper cars. Some merged to become the planets we know today. Others were kicked out entirely, ejected into interstellar space. Planet Y might be one of the lucky survivors, massive enough to hang on in a stable orbit at the fringes. Another possibility is way cooler. Maybe it's a rogue planet. Planet Y might just be the cosmic equivalent of an adopted kid or a wandering stray that found a home. So what would it mean if Planet Y was real? First, it would mean a lot of textbooks getting another edition. New picture books as well. It would also challenge how we think planets form. A Mercury to Earth mass that far doesn't fit the standard model of planets forming near the Sun and staying put. Either the early solar system was wild enough to fling it outward and still keep it bound, or it didn't start here at all and was captured later, stolen from another star. There's another angle. Comets. A planet out there could tug on icy bodies at the edge of the solar system, nudging some inward. Over time, that might even have helped deliver water and building blocks for life to Earth, but that's just speculation at this point. However, the biggest question of all would be, what else is out there? If a planet the size of Earth can still slip under our radar, then smaller worlds, icy dwarfs, and other mysteries could be waiting farther out. The Oort cloud might be home to things we haven't even dreamed of yet. Finding Planet Y wouldn't just add a planet, it would open a new chapter in exploring the solar system. So, here we are at the edge of the map, where the streetlights of our solar system flicker out. It's just another theory on top of a dusty desk. Another clue to chase down a dark universe. Some leads have gone cold and turned out to be ghosts. Others, still out there, waiting to be found. Planet Y? The case is still wide open, but one thing's for sure in our solar system. As long as the orbits keep wobbling and the cosmic rug stays wrinkled, astronomers, they'll keep looking. They'll never stop searching for the last planet hiding in the endless dark. Maybe it's just a matter of time. We will see.
Hey, scientists may have just found a new planet that looks a lot like Earth, with a big icy catch. This world is about 150 light-years away, rocky, and circles a sun-like star on a schedule pretty close to ours. At first sight, it sounds promising, right? Well, slow down. There's a catch here. It might be insanely cold as Mars in the deep freeze. You see, HD 137010b, that's a mouthful, doesn't seem to be a gas ball, so we would probably be able to stand on its surface. It's a little bigger than Earth and goes around a star that's pretty similar to our Sun. This star is about 146 light-years away from our planet, which, in space terms, is close enough for scientists to study it instead of just, squinting at it. But what made people excited is the fact that this planet takes about 1 Earth year to go around its star. Now that's a big deal, because most exoplanets dash around their stars in days or weeks. Even better, this newly discovered one might sit right on the outer edge of the habitable zone, also called the Goldilocks zone. This region is not too hot and not too cold, which means that liquid water might exist on the planet if it has the right atmosphere. A big if, but still cool. Another thing that makes this planet extra special is how we see it. From Earth, it actually passes in front of its star. Imagine a tiny bug crawling across a flashlight beam. You got it. That makes it way easier for scientists to study things like its size, orbit, and maybe even what its atmosphere is made of. And if all of this checks out, it could be one of the best Earth-like planet candidates we've ever found. And now, the bad news. This planet does not get much sunlight. HD 137010b gets less than 1/3 of the heat and light Earth gets from the Sun. Even though its star is similar to our Sun, it's basically the Sun's quieter, dimmer cousin. You know, same type, lower wattage. What does that mean for the planet? It could be insanely cold. Scientists think the surface temperature might max out at around minus 90 degrees Fahrenheit. And that's not a grab-a-jacket cold, that's your face freezes right away cold. For comparison, Mars has an average temperature of around minus 85 degrees Fahrenheit. So this planet could actually be colder than Mars, a frozen desert, not to be confused with a frozen dessert, that looks like it gave up on life a long time ago. Another plot twist. This planet isn't officially a planet yet. At the moment, it's still labeled a candidate. Scientists usually confirm planets by watching them pass in front of their star over and over again. Every time that happens, the star dims just a little bit. But with this new space body, we've only seen one transit, a single 10-hour-long mini-eclipse, spotted during Kepler's second mission, called K2. Even with that one pass, astronomers could still learn a lot. They measured how long the planet's shadow took to cross the star, about 10 hours. For comparison, Earth takes about 13 hours to cross the Sun. Then, they plugged that into orbital models and estimated that the planet probably takes about a year to go around its star. That's impressive, but it's still not enough. Astronomers need to see that dip in starlight repeat on schedule to be sure it's really a planet and not some weird stellar wanderer. Unfortunately, this planet orbits far out, and those transits are rare. You don't get one every few days or weeks. You might have to wait a year or more for the next one. That's one of the big reasons Earth-like planets are so hard to find in the first place. So now, scientists are just hoping that other space telescopes can help out. NASA's TESS might catch another transit, or Europe's Cheops telescope could help pin it down. If neither of those catches it, we might have to wait for the next generation of space telescopes to get better data. Because even though this planet sounds like an ice cube in space, it's not totally doomed. If it has a thick atmosphere, especially if it's rich in carbon dioxide, it could trap heat really well, like a planet-sized winter coat. In that case, the planet might actually have a mild climate or even liquid water on its surface. Well, based on computer models, scientists say there's about a 40% chance this distant world sits in the safe, conservative, habitable zone. A chance that is located in a more relaxed, optimistic habitable zone reaches 51%. But there's also a 50-50 chance that the planet is actually outside the habitable zone altogether. In other words, this planet is basically a cosmic coin toss. It could be a frozen wasteland, worse than Mars, a chilly, barely survivable world, or a watery planet hiding under a thick atmosphere. HD 137010b isn't the only place that has the potential to host human civilization in the future. In recent years, astronomers have been spotting new super-Earth planets orbiting remote stars. Now, checking our space vocabulary, super-Earth means a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. One of those planets is Gliese 667cc. It's just 22 light-years from Earth. But even though it seems pretty close, it's still around 129 trillion miles away from us. That's around 1.4 million times the average distance from the Earth to the Sun. So very, very far. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares from its parent star. Then there's Kepler-22b. This world is way farther away than the previous world, more like 600 light-years away from our planet. It's larger than Earth and is about 2.5 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler-22b is pretty similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kinda similar to our Sun. But this star is smaller and colder than ours. Now, don't confuse this world with Kepler-69c. It lies a whopping 2,700 light-years away from us and is almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 242 days to complete one orbit. This makes its position in its system similar to that of Venus in our solar system. At the same time, this world might be more hospitable than Venus since its host star is a bit less luminous, 80% of our Sun. As for our Venus, it's an extremely hostile place. You don't want to go there. A runaway greenhouse effect caused by an atmosphere that's about 96% carbon dioxide traps the heat. That pushes surface temperatures up to around 878 degrees Fahrenheit, which is hot enough to melt lead. On top of that, the air pressure is about 90 times stronger than that of Earth, and the whole planet is covered in thick clouds of corrosive sulfuric acid. Oh boy. Compared to our neighbor, TOI 733b seems like a pretty friendly world. This planet was found in 2023. It's floating 245 light-years away from Earth. The coolest thing about this planet is that it might have a massive ocean. According to scientists, this planet is likely to be completely covered with water. Does it mean there could be life on this super-Earth? Well, time will show. And who knows? Maybe soon we'll find even more planets that could become a new home for people looking to explore the universe. As for HD 137010b, the fact that it checks so many Earth-style boxes makes it a really interesting find. It's not a backup Earth yet, but it makes scientists stop and say, okay, this one's worth a closer look, or something similar.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, It's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures and pressure and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. we could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere. Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, They constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet, a doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems. But this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper Belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. It's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system. I mean, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRIS database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between Iris and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they've discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide.
Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle, but those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be 2 unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers used different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth, it's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet. So, planets with 2 suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. 2 stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting 2 stars like it's no big deal. This planet lives closer to its 2 parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The 2 suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When 2 stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. when a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new: planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all.
Take that giant space knife. Yes, you. It's time to visit the sun and check what's inside. First, you're slicing through the corona, aka the sun's wild hair. It's the sun's super thin atmosphere, but don't let it trick you. It's blazing at 3.5 million degrees Fahrenheit. While cutting through it, you see plasma threads whipping around like solar spaghetti. You reach the photosphere, the sun's skin. It's only about 300 miles thick, but it's super bright and sizzling at 10,000 degrees Fahrenheit. Looks like it's covered in little fiery waffles. They're called granules, and they're each about 600 miles wide. Then comes the convective zone, where hot plasma is floating up in bubbly chunks. Next, the radiative zone. This part's like molasses made of light. It takes 170,000 years for energy to crawl through here. Finally, you start cutting into the core, and boom! Instant heat wave. It's like the sun's pressure cooker. Gravity's smashing hydrogen atoms together to make helium, and it's cooking at 27 million degrees Fahrenheit. Now, you're gonna need a smaller knife, since the next candidate, Mercury, is the smallest of the inner planets, only about 3,000 miles wide. When you cut through its thin atmosphere, you see little hydrogen and helium atoms escaping inside tiny invisible balloons popping away into space. Next, the crust. Together with mantle, it's only about 250 miles thick. As our giant knife passes through, you see hard rock flakes falling off, cracking under the pressure. Mercury has a gooey outer metal core. Slice carefully, or you'll spill some liquid metal lava. Finally, you hit the inner core. Mercury has a massive metal heart. Around 85% of the whole planet is just iron and metal. It's basically a giant metal meatball. Cut through it and watch molten iron juice oozing out like spicy hot sauce. You're now approaching Venus, the hottest planet out there. We're talking about average temps of 870 degrees Fahrenheit. Hot enough to melt lead. You slice through the atmosphere and it's crazy. Thick clouds of sulfuric acid swirling everywhere, and it's mostly carbon dioxide. Like a bad greenhouse on steroids. Pressure there is insane, like being 3,000 feet underwater on Earth. Thick yellowish clouds are puffing around the blade, sizzling like acid rain. Then comes the crust. A thin shell of mostly basalt, just 6 to 18 miles thick. It's like cutting through a crispy rock pizza crust, thin but tough. Cut deeper and you're in the molten rock mantle, about 1,800 miles thick. You can see the rocky magma wiggle and ooze. Finally, you hit the metal core, about 1,900 miles wide. That's like slicing a chunk almost the distance from Chicago to LA. There's a giant iron ball inside, all molten and heavy. Alright, time to cut through Earth. Now you might need a whole chainsaw to deal with this rocky planet. First, your chainsaw bites into the crust. It's thin, only about 1% of Earth's volume. You hear a sharp crack as the brittle rocks snap and crumble. Dust and tiny minerals puff out, and the crust breaks into chunks, like snapping a hard cookie. Next, the blade presses deeper into the mantle. Thick, tough rock that's solid but kinda squishy if you wait long enough. As you slice, the hot rock kind of oozes and bubbles, leaving a warm trail along the blade. Keep going, and you hit the outer core, a huge sea of molten metal. Suddenly, the knife slides through thick, glowing liquid iron and nickel, like cutting through a giant cosmic lava lamp. Finally, you smash into the inner core. Solid metal this time, like a glowing steel marble buried deep inside. The blade scrapes across its dense iron-nickel surface with a harsh grind. It's blindingly bright and insanely hot here, hotter than the surface of the sun, and the pressure would squash any real blade flat. Put the chainsaw aside. For the next planet, you'll need something of a more modest size. You're zooming over to Mars, the last of the rocky inner planets. The knife breaks through Mars's crust. It's thin and solid, made of volcanic basalt rock. As the blade cuts in, fine reddish dust, like cosmic talcum powder, puffs up, drifting everywhere. The crust doesn't crack into big plates like Earth's. It's one big solid shell. Next up, the mantle. Think of it like thick, soft, rocky toothpaste. Not totally solid, but not mushy either. The knife slides through it with some resistance, and you see glowing silicate goo in red and orange shades, swirling around the blade. The mantle is thinner than Earth's, only about 800 to 1,100 miles thick, so you don't have to wait long to get to the juicy middle. Finally, you hit the core, a metal mix of iron, nickel, and sulfur. Mars's core is molten, but it's cooler and more chill than Earth's. In any case, it's easy to cut through, no effort needed. We're coming close to Jupiter, the biggest dude in the solar system. Jupiter is a gas giant, basically a giant balloon filled with crazy stuff. As you cut it, you don't hit solid ground at first. Instead, it's all thick, swirling gas, mostly hydrogen, around 90%, and helium. It must feel like slicing into super thick whipped cream that never ends. As you go deeper, the gas gets so squished that it turns into a thick liquid. The blade pushes through layers of swirling storms and colorful clouds that whirl around. Keep going, and the gas becomes metallic hydrogen. The knife slices through a glowing, electrified liquid that crackles around the blade, like you're cutting through electric jelly. Finally, somewhere way deep inside, you reach the core, which might be a molten hot ball of liquid or a giant rock heavier than 14 Earths. Nobody's totally sure. But if you could slice through it, the core would be hotter than 43,000 degrees Fahrenheit. A regular blade would melt instantly or be crushed from all that pressure. It would be pretty tricky to cut open the next planet, not because it's too hard or rocky, but because there's basically nothing to cut through. In Saturn's outer layer, your knife hits thick, swirling gases, mostly hydrogen and helium, but with some funky extras like methane, ammonia, and water vapor. As you cut, a smoggy orange haze puffs out. That's all the sulfur giving Saturn its groovy look. The atmosphere and surface blend together. No hard ground here. As the blade digs deeper, the gas gets squeezed tighter and tighter. Hydrogen starts turning into thick liquid, and your knife leaves trails through this gooey, glowing layer. Keep going down, and suddenly, the liquid gas turns into metallic hydrogen, shiny and electric, crackling around your blade like a sci-fi lightsaber. Deep inside, you might hit a rocky core, but no guarantees. It might even be liquid rock, glowing and swirling beneath all that gas. Next, we're gonna split open an ice giant, Uranus. Its atmosphere has enough methane to give the planet that cool blue-green glow. As your blade moves, a faint icy mist sprays off. It's like slicing through a cold, foggy cloud. Next, you slice into the ice mantle, which makes up about 80% of the planet. But don't think frozen popsicles. This is a thick, hot, gooey soup of water, ammonia, and methane ice. The blade pushes through this dense, slushy ocean with little bubbles and steam escaping as you go. Then, bam! Blade hits the rocky core, small and dense, half as heavy as Earth. It's cooler than most cores, about 9,000 degrees Fahrenheit, which is still crazy hot. The blade scrapes over solid rock with sparks flying off like cutting metal in a cold workshop. Neptune's also crazy cold, but cutting it feels different. When cut, it whips clouds of frozen methane flying past at 1,200 miles per hour. It feels like slicing through a freezing, super windy blizzard. Next, you plunge into the mantle, a thick, boiling hot soup of liquid water, methane, and ammonia. The knife pushes through this dense stew with bubbles popping and steam hissing. Temperatures here range from 3,000 to 8,500 degrees Fahrenheit. Even deeper, the blade hits Neptune's solid core, mostly iron, metals, and silicates. The blade scrapes along this tough metal center, sparks flying like you're welding the heart of the planet. Now, comment below, which planet was the most satisfying to cut through? Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Bernard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Bernard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Bernard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Bernard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Barnard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super-sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Barnard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real Smartie. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation. This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 10007b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 10007b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky. Those sound clouds are way up there in the penthouse suite of WASP 10007b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 10007b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. And it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest nightside temperature ever recorded. To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals, which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called... Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. This hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, it's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1,700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth, and its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri E is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. Some time ago, the James Webb Space Telescope spotted a super bizarre space object flying through our galaxy. First of all, it's not orbiting any star. It's a rogue object, just drifting through space on its own. Even better, this wandering thing apparently has a cake-like atmosphere, and examining it can be crucial in our future exoplanet research. Plus, it can help us understand how gas giants evolve over time and what might happen to Jupiter in the future. You may object that Earth has a layered atmosphere too, with 5 major and several secondary layers. But on Earth, the air is mostly nitrogen and oxygen. As for other planets, they're different. Take Venus, for example, where the atmosphere is super thick and filled with sulfuric acid. There are exoplanets with water vapor clouds, or ones where the clouds are literally made of hot sand. But what about our rogue object? By the way, I have no clue why it got this reputation, but for some reason, scientists chose to call it SIMP. Ouch. Anyway, it seems to have its own unique combo, with cloud patches and weird chemical reactions happening high up. It is covered in clouds made of iron and magnesium, and its atmosphere has carbon-based chemicals floating around. Scientists have spotted auroras on it. Yep, like the northern lights we have on Earth, but way out in deep space. It's the very first time researchers have been able to do a sort of weather report on a rogue object like this. The next weirdness? The object doesn't really fit into any box. It's not a regular planet, because it doesn't orbit a star. But it's also smaller than a brown dwarf, which is something like a failed star. So it's something in between. Not quite a planet, not quite a star. And while it's not dangerous in the we're all doomed kind of way, scientists say rogue objects like this could actually mess things up pretty seriously if they wandered too close to a solar system. Their gravity might throw off the orbits of planets, which could lead to instability, or even space collisions. So yeah, while our rogue friend is not a threat right now, it might become one in the future. Now, this rogue object has some crazy stuff going on. First off, its day is only 2.4 hours long. Like, imagine the sun rising and setting in that time. That's real fast. It's also hanging out about 20 light-years away in the Carina Nebula, which isn't super far in space terms. Another thing that makes this guy special is the fact that it's the brightest free-floating object of its kind that we can see from the northern hemisphere. And since it's just drifting in space without a nearby star messing with our view, it's been directly photographed by telescopes, like NASA's Spitzer. That's actually super rare for stuff this faint and far. When scientists checked it out in infrared, aka heat vision, they noticed that the atmosphere of this rogue object was acting weird, like it kept changing, sometimes more heat, sometimes less. Something funky was going on, but what exactly? So, in July 2023, one team of scientists used the James Webb Space Telescope to dig deeper. They pointed it at SIMP and gathered a ton of data, around 6,000 measurements in just a few hours. First, they looked at shortwave radiation, which is kind of like high-energy heat, and then they did the same with longer waves a few hours later. They discovered that the brightness changed differently depending on the wavelength. Some parts of the atmosphere got brighter, some dimmer, and some didn't change at all. It was all over the place, but they noticed a pattern. All the changes fell into 3 groups. Each group had its own vibe, like its own little signature of what was going on in the atmosphere. And it turned out that the mysterious object wasn't just floating alone in space. It was super dynamic, with layers of clouds and gases doing their own thing. It could mean 3 different things were going on in the atmosphere. To figure out what exactly was behind all this, they built models of the rogue object's atmosphere. Apparently, the first group of curves likely came from low clouds made of iron. Yeah, iron, like actual metal clouds. The second group seemed to come from higher clouds made of this mineral called forsterite, which is basically a magnesium-rich crystal. and it looks like these cloud layers aren't smooth, they're patchy. That patchiness could explain why the light coming from them keeps changing so much. As for the third group of light patterns, they weren't coming from clouds at all. The light seemed to be coming from way above the clouds, from what they think are hotspots in the atmosphere. These hotspots are probably connected to radio auroras, kind of like Earth's northern lights, but happening in the radio part of the light spectrum instead of visible light. But even after all that modeling, there were still some mysteries left. Like, the first group of curves was all over the place, more than they expected. So they think it might be because of carbon-based gases like carbon monoxide floating around. They might absorb certain types of light at random times. In any case, this is the first time we've actually seen this kind of atmospheric chaos directly. But the few hours the researchers spent watching it weren't enough to fully figure it out. To really get the full picture, they'll need days of data, and they're hoping to use NASA's Nancy Grace Roman Space Telescope, set to launch in 2027, to dive even deeper. Even though this mysterious object is not a rogue planet, they're definitely worth mentioning. These are basically planets that got kicked out of their home solar system. Yeah, like straight up evicted. When a planet forms, it's usually hanging out with a bunch of other planets around a star. But early on, things can get super chaotic. You know, planets crashing, shifting, getting too close to each other. And sometimes, one gets yeeted right out of the system. So, since they're not tied to a star, these rogue planets are just cruising through the galaxy, totally solo. If they happen to float near something massive, like a star or a black hole, that thing's gravity can tug at them. But otherwise, they just keep drifting. Most of them probably got booted when their system was still forming, and everything was a mess. But according to a NASA scientist, even mature systems can throw a planet out if the orbit gets too weird or something big knocks into them. Now, the next planet we gotta discuss isn't rogue. It has a parent star and all. But there's another cool thing about it. It's still a baby in the middle of forming, and it's pretty rare to catch in action. The baby is already about 3 times the size of Jupiter, the largest planet in the solar system. It's part of a system about 400 light-years away. It's been growing for about 5 million years, munching on gas and dust from the disk around its star, kinda like a cosmic buffet. But the thing is, when astronomers checked out the chemicals in the planet's atmosphere using a big telescope in Hawaii, things didn't add up. They were specifically looking at carbon monoxide and water, which can help figure out how much carbon and oxygen is floating around in that atmosphere. Turns out, the planet's chemical mix doesn't quite match the stuff in the disk it's forming from. That's a big deal because it goes against what scientists thought they knew about how planets are supposed to form. Basically, it's saying, hey, your fancy models might be a bit too simple. Planets are supposed to form by clumps of gas and dust crashing into each other and sticking together. Over time, they build up into full-blown planets. If that's true, then planets and their surrounding gas should have the same kind of stuff in them, chemically speaking. But PDS-70b is doing its own thing. So the scientists came up with 2 ideas to explain what was going on. It might be forming from solid stuff, like dust and ice, not just the gas in the disk. That solid material has carbon and oxygen trapped inside. So, by the time it melts and goes into the planet, it's already changed the chemistry. Or the gas in the disk got more carbon after the planet already formed. Luckily, there's another planet in the same system, PDS-70c, and scientists are hoping that by checking it out too, they'll be able to figure out the truth.
Saturn's rings. Impressive, right? But look closer. They're crooked. Actually, the whole planet is tilted by nearly 27 degrees, which is way more than it should be. Look at its neighbor, Jupiter, for example. It has a tilt of only 3 degrees. So, what happened to the Lord of the Rings? A new study suggests that Saturn used to have a huge extra moon. Yeah, besides the other 274 it currently has. But who's counting? Millions of years ago, that space rock might have crashed straight into Saturn's largest moon, Titan. The collision was so massive that it could have knocked the planet off balance, leaving it even more tilted than before. This extra moon hypothesis is a pretty good one, but to fully understand it, we first need to look at previous theories on why Saturn is tilted in such a strange way. Theory number 1. Blame it on Neptune. Poor guy, this planet is about 1.8 billion miles away, but he ended up becoming the main suspect. For years, astronomers believed Neptune's gravity slowly pulled Saturn over onto its side over billions of years. They thought the two planets were locked in something called orbital resonance that happens when two moons or planets sync up and start pulling on each other in a regular rhythm. Well, here's the thing. A planet's orbit is massive and carries a huge amount of energy, while the way a planet spins is much, much weaker. So, when you lock these two motions together, I mean Neptune's orbit and Saturn's spin, it's Saturn's spin that's going to change and end up tilting. That's the power of orbital resonance. But then, Cassini happened. Back in 1997, NASA launched this spacecraft to explore Saturn and its icy moons. Cassini stayed out there for 13 years, and it shared some really interesting discoveries, including the fact that, nope, Neptune is not our guy. Cassini's data showed that the two planets aren't exactly in sync. So that couldn't explain Saturn's crooked posture. Something was missing. But what? That leads us to theory number 2. It's Titan's fault. Poor guy, he was just there, hanging out as Saturn's largest moon, when suddenly he became suspect number 2. Okay, to be fair, it's more like Titan is the leader of the gang, but the other moons are helping out too. Two scientists from France came up with this theory in 2021. Back then, we already knew that Titan and the other moons were moving away from Saturn. But their observations showed this is actually happening much faster than we thought, at a rate of about 4 inches per year. Yeah, really. Eventually, Titan could even be kicked away from Saturn's orbit entirely. And this whole process actually messes with the way Saturn leans. As the moons drift further away, the planet just tilts more and more. This explains why Saturn is still actively leaning today. In fact, over the next few billion years, the planet's tilt could more than double. Well, that's all pretty interesting, but it doesn't explain one big mystery. Saturn wasn't always that crooked. Some scientists believe that for over 3 billion years after the planet first formed, its lean was actually pretty small. So, something must have happened to change all that. Something big. That's how we got to theory number 3. It's Chrysalis's fault. And again, poor guy, this hypothetical moon might not have even existed, and we're already blaming it. Back in 2022, scientists came up with an idea about a lost moon called Chrysalis that vanished about 160 million years ago. This theory says Chrysalis orbited Saturn for billions of years, helping keep the planet in sync with Neptune. But then, things took a turn. As the moon spiraled inward, Saturn's massive gravity didn't just pull it in, it literally ripped the moon to shreds. Losing Chrysalis's weight and its gravitational pull was like a cosmic kick. It broke Saturn's old connection with Neptune and knocked the whole planet over on its side. In other words, its disappearance could be the reason why those two planets aren't perfectly aligned anymore. Now, even though the moon's solid body is gone for good, its remains didn't just vanish. They flattened into one of the stunning rings we see today. I mean, the exact same thing that tilted the planet also gave it its most famous feature. So, basically, Saturn's famous ring system used to be a moon. Well, how cool is that? Anyway, scientists decided to test this out. But when they recently ran some simulations to see exactly how it all happened, they found a problem. In most of those versions, Chrysalis didn't actually hit Saturn. Instead, it crashed into the megamoon Titan and merged with it. But Titan wasn't Titan back then. There might have been an earlier version of Titan that was a lot more massive than Chrysalis was theorized to be, about 4 times as big. Here's what the team thinks really happened. If we go back 400 million years, Saturn looked completely different than it does now. There were no rings, and it had a different set of moons than the ones we see today. Back then, 2 of them were huge. Let's just call them Moon A and Moon B. At some point, Moon A's orbit shifted and got locked into what's called a 2-to-1 resonance with Moon B. Basically, that means for every one time Moon B went around Saturn, Moon A went around twice. That rhythm caused Moon A to start moving inward pretty fast. Eventually, the inevitable happened. They slammed into each other. That collision ended up doing two main things. First, Moon A was pretty much destroyed. A huge chunk of it crashed onto the surface of Moon B, while the rest turned into a giant cloud of debris. Eventually, all those leftover pieces clumped back together into one piece, which became the current moon, Hyperion. The theory actually explains why Hyperion isn't a perfect sphere. It's shaped more like a potato. As for the rest of it, the part of Moon A that hit Moon B merged right into it. Together, they formed the version of Titan we know today, a massive icy moon that's bigger than the planet Mercury. Now, this merging process might also be what created Saturn's rings, maybe about 100 million years ago. As Titan's orbit expanded, it messed with some of Saturn's inner moons, shaking them up until they eventually smashed into each other. Some of that leftover debris stayed behind and became the rings we see today. But we can't say for sure if that's exactly how it went down, mostly because we still don't know how old Saturn's rings really are. So not every scientist is totally sold on this theory yet. Take NASA researcher Linda Spilker, for example. She says this study makes a really strong case that Hyperion and Saturn's rings actually showed up long after the planet itself was born. But the truth is, the rings could be much older than that. And if that's the case, the timing for this theory really doesn't line up. That means we'll have to wait for more proof before we can say for sure. But the answer might be coming soon, thanks to NASA's $3 billion Dragonfly mission. And the whole idea is to explore Titan up close. This is a spacecraft about the size of a Mini Cooper that works a lot like a high-tech drone with 8 rotors. It's scheduled to launch in 2028 and should arrive at Titan by late 2034. Once it gets there, it's going to spend about 2.5 years exploring different spots all over the moon. Since it has propellers and landing skids, it won't be driving on the ground like a rover on Mars. Instead, Dragonfly will travel by air. It'll take off vertically, fly to a new location, and land again, basically hopping across the moon. The mission might finally give us the answers we need. Dragonfly could test this theory by looking for geological or chemical signs of a huge crash between two moons a long time ago. And if it finds them, bingo! One of Saturn's greatest mysteries will finally be solved. Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet. So, the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars Insight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe. Well, NASA has just dropped the craziest news ever. They've found the clearest evidence yet that life might have once existed on Mars. So, is that what you'd see if you travel there? Well, let's imagine, shall we? The world around you is red, darker than Earth. There's a dust storm on the horizon. Suddenly, you spot a bizarre creature that makes your blood run cold. It's way taller than you, with long, creepy-looking arms and legs. Its skin is orange, and its eyes are huge. They look like some kind of shiny lenses. Come to think of it, it all makes sense. Gravity on Mars is 38% weaker than on our planet. That's why this creature has grown to be so tall. You know, when astronauts go to space, they tend to grow up to 2 inches. All because the reduced gravity makes the fluid between their vertebrae expand. As for the creature's unusually colored skin, this is protection against solar radiation. Mars doesn't have a global magnetic field. There's nothing to protect the planet from radiation. And the locals' bodies probably had to switch their pigmentation from melanin to carotenoids, the same pigments that give oranges, carrots, and tomatoes their bright color. As for those big, beautiful eyes, they help the creature perceive the light of our now-distant sun much better than regular human eyes. Now, if this is the story you wanted to hear, I'm sorry to disappoint you, because the life forms we've discovered on Mars are very different, and still, for scientists, they are no less exciting. Last year, the Perseverance rover, the most expensive off-roading robot ever, found a dried-up riverbed covered in weird, rusty circles they're calling leopard spots. According to a scientist from NASA, these spots might be leftovers from ancient life forms that lived there billions of years ago. And now, experts think they might know what those tiny Martian critters could have looked like. Once again, we're not speaking about creatures with eyes or tentacles here. Mars is a wild place. It gets roasted during the day, then drops to minus 225 degrees Fahrenheit at night. There's low gravity and nasty radiation there, so anything living out there would have been microscopic, bacteria-level small. If, and it's a big if, something more complex ever evolved on the red planet, it would have needed insane superpowers to survive those conditions. Anyway, while cruising around an area called Bright Angel, Perseverance spotted those leopard spots. Scientists call them reaction fronts, basically places where chemical stuff went down long ago. The rover found 2 minerals in these spots, vivianite and greigite. On Earth, vivianite shows up when organic stuff rots, and greigite is made by microbes, tiny living things. One of the scientists on the team said those minerals look exactly like the kind we find when microbes are involved here on Earth. In his words, this could be the most convincing evidence of life on Mars so far. Of course, there was still a chance these patterns had been made by non-living processes. Nature could have been doing its thing without any help from space germs. But after a year of tests and reviews, and probably a lot of coffee, the team says they're confident this could be a real biosignature. So, what would this Martian life even look like? You see, today, Jezero Crater, a big impact basin just north of Mars's equator, is basically just a dusty wasteland. But billions of years ago, that place was full of water, a real Martian pond. Scientists think that the crater back then had cold, water-rich spots that were perfect for little microbial life. Those microbes could have munched on stuff like carbon, sulfur, and phosphorus in the rocks, and the minerals they produced could be what we see today as those leopard spots. Now, even though the surface conditions on Mars were insane, with freezing temps and all that radiation, microbes could still make it work, just barely surviving day to day. Experts point out that there was actually liquid water at that time, so it means the red planet was technically habitable. Now, since all we've got are these tiny traces, we can't say exactly what Martians looked like or how they acted. But we can make some educated guesses by looking at Earth. We could compare the microbes from Mars with extremophile bacteria on our planet, those tough little guys living in salty lakes, deep underground, or in deserts so harsh even cacti wouldn't bother. Another question is, could anything bigger or fancier than microbes have ever evolved on Mars? Probably not. If those leopard spots are actually signs of life, scientists think microbes weren't just hanging out in one spot. They were likely all over the place. Perseverance is checking out ancient rocks beyond Jezero Crater to see if Mars had a bigger population. But here's one thing. Mars got harsh very fast. Life may have popped up on this planet around the same time as on Earth. But after about 1 billion years, the red planet started losing its atmosphere thanks to solar winds. That turned Mars into a freezing, dry wasteland. The extreme cold, radiation from the sun, and lack of water would have made it super tough for anything bigger than microbes to survive there. Complex life, like animals, took another 3 billion years to appear on Earth, and conditions on our planet were way more pleasant. If anything more advanced ever showed up on Mars, it would have had to be like a superhero microbe with thick skin or an ability to hide underground to dodge UV rays and survive in freezing temperatures. It would have been living off whatever tiny puddles of water it could find, basically like desert lizards or those weird filter feeders you find near Earth's hydrothermal vents. Now, we might still need to wait before we meet a real Martian resident, but nothing can keep our imagination from wandering. So, how about we sneak a peek at what the inhabitants of other planets of the solar system would look like if they existed and were more complex than microbes? Now, if it was a creature from Jupiter, it would probably be something like a deep-sea tank bug with a thick armored shell, huge googly eyes, webbed claws, and gills. All those features would help it survive Jupiter's crazy high pressure, radiation, and endless liquid layers. Because on this planet, at first, everything is just clouds. But go deeper, and gas turns into a liquid ocean of metallic hydrogen. No wonder locals would need all the protection they could develop. Let's jump over to Saturn with its clouds, rings, and more clouds. This planet is so light it could literally float in a giant cosmic bathtub. Here you'd likely come across a giant space jellyfish. It'd float through thick fog with an umbrella-shaped body and long tentacles instead of arms. Saturn's pressure is huge, and having a skeleton would just get it squished. Floating and flopping around is the smartest survival hack here. Now we're going to visit the ice giants, Uranus and Neptune. Both planets are like cosmic slushies of ammonia, methane, and water. Boy. There's no solid ground anywhere, just icy oceans under thick atmospheres. Here, you might meet a stocky, muscled amphibian with stubby limbs, webbed fingers, and scaly skin. All because gravity on the ice giants is higher than on Earth, and the environment is freezing. Any creature living there would need short, strong limbs to survive crushing pressure, swim through icy oceans, and stay warm. Moving back to our neighborhood, the first stop is Mercury. The sun here is so close, it looks 3 times bigger than on Earth. Temperatures swing from instant frostbite to literal oven. If anything could survive here, it'd probably have titanium skin. It would be smooth all over, and sunglass-like eyes would protect it from ultra-bright solar rays. The thing is, Mercury has almost zero atmosphere and intense sunlight. Anything living there would need a body capable of surviving heat and radiation without melting or burning out. Our final stop is Venus. The pressure there feels like you're a mile underwater. Volcanic eruptions are popping off all the time, and the air could melt lead. Tropical. and life forms here would be downgraded to a microscopic blob. No arms, no legs, and certainly no face. Venus is insanely hostile, crushing pressure, molten hot temperatures, and toxic gases. Only tiny microbial life could probably survive here. Given all that, I'll take Hawaii instead.
Picture a tiger. Tigers are known for their beautiful stripes, which they always keep the same. However, imagine if the tiger's stripes could change their size, position, and colors from time to time. Magical, right? But that's exactly what happens with one titan of our solar system, Jupiter. Why and how? Well, astronomers might just have the answer, so let's see. Jupiter is a huge and fascinating planet. When you're looking at its picture from far away, it's like seeing a beautiful sunrise. Here we have an entire palette, from creamy pale yellows to caramel browns, with even some blue shades. Jupiter is a fascinating place made mostly of hydrogen and helium, just like our Sun. However, it didn't gather enough stuff during its formation to become a star. Instead, it became a colossal ball of gas that could fit more than 1,300 Earths inside. Jupiter has these interesting patterns of dark and light clouds that go around the planet in alternating bands, like giant stripes. These dark stripes are called belts, and lighter ones are called zones. Actually, it's not unique in this. Earth and Jupiter both have these cool patterns in their atmospheres. It's just that Earth has a few of them, but Jupiter has a lot more. Why are these belts brown and beige? Those can be explained by the combination of hydrogen, helium, and other trace elements in the planet's atmosphere. It's like mixing different colors of paint to create new shades. These belts create beautiful patterns across the planet's surface. Now, because Jupiter has such a massive atmosphere and a weather system similar to Earth's, it experiences some extraordinary storms. So even though these stripes may look calm and peaceful, they're actually part of a wild weather system. It's like a never-ending storm party happening there. These belts and zones move in opposite directions around the planet. The belts go against Jupiter's rotation, like going against the flow, while the zones go with it, joining the dance. And not only do they move in different directions, but they also exist at different heights in the planet's atmosphere. The belts are like regions where things are rising up, like bubbles in a fizzy drink. So the cloud tops in the belts are higher up in the sky compared to the cloud tops in the zones, which are more like sinking areas. So, even though Earth and Jupiter have this similarity, their weather is completely different. It's like comparing apples and oranges. One of the most famous storms on Jupiter is the Great Red Spot. But why is it red? Well, that's a bit of a mystery. Scientists think that the storm sits at a higher altitude than the rest of the atmosphere. This means it gets a stronger dose of sunlight. Imagine standing on a hilltop where the sun shines brighter on you compared to the surroundings. In a similar way, the Great Red Spot gets more radiation from the sun. The storm also contains some special chemicals in its clouds, like ammonia and acetylene. When these chemicals receive that extra radiation, they react in a unique way, giving the storm its distinct red color. It's like a special effect in a cosmic theater. Anyway, the stripes look pretty cool and all. But what's the big mystery around them? Well, you see, one day scientists decided to look at data from deep inside Jupiter, about 30 miles below the surface. And after peeking in Jupiter's secrets, they noticed something strange. When they looked at Jupiter using a special type of light called infrared, the colors of its stripes actually switched around. The light bands that were pale and creamy in normal pictures become dark in the infrared view. The dark bands that were belts before now shined brightly in the infrared. This suggests something interesting. The belts on Jupiter have thinner cloud coverings compared to the zones. It's like the belts are wearing sheer, see-through outfits, while the zones have thicker clouds, like fluffy jackets. So, what we see as dark bands in normal pictures turn out to be bright in the infrared, hinting that these belts have less cloud stuff blocking the light. But here's the most strange part. Every few years, something changes. It's like the weather on Jupiter goes through a wild roller coaster ride. The colors of the belts can change, and sometimes the whole weather pattern becomes a bit crazy for a while. Scientists have been scratching their heads, trying to figure out why this happens. So they've decided to use a special spacecraft called Juno to investigate this. Since 2016, Juno has been gathering a lot of information about Jupiter, like a spy collecting clues. One of the things Juno has been looking at is Jupiter's magnetic field. Just like Earth, Jupiter has a magnetic field. It's like an invisible bubble that surrounds the planet, extending to space. This magnetic field is really important because it protects the planet and everything on it. It acts like a shield against harmful particles from space, like those coming from the sun. But Jupiter's way bigger than us, so his protective shield is much stronger. Magnetic fields are generated by something called a dynamo, which is like a big swirling conducting fluid inside the planet. This fluid moves around and rotates, kind of like a dance party happening deep within the planet. So, scientists have been looking at the data collected by Juno over the years and noticed something interesting. Jupiter's magnetic field has its own little motions, kind of like when you see waves in the ocean. Scientists call these motions torsional oscillations, which is just a fancy way of saying wave-like movements. It's like Jupiter is doing its own magnetic dance. Now let's imagine that Jupiter's insides are like a giant pot of boiling soup. Deep within Jupiter, there are slow currents that carry heat upwards, just like a conveyor belt. This heat eventually reaches the upper part where we see the clouds. But here's where things get interesting. Imagine someone starts stirring the soup really fast with a spoon. Those wavy magnetic movements, the torsional oscillations, act just like that spoon. They create a disturbance that messes up the slow currents. Now this disruption has a big impact on Jupiter's weather. It's like turning up the heat in the kitchen and changing the way the soup cooks. The patterns of rising and sinking in the clouds, which we call upwelling and downwelling, get all mixed up. A whirlwind in the soup. Our clever scientists also noticed something special near Jupiter's equator. They discovered a concentrated spot of magnetism called the Great Blue Spot. And guess what? This spot is slowing down, like it's taking a break from its usual fast movement. This suggests that a new type of wavy motion, a new dance, is about to begin. So, to sum it all up, the scientists have come up with a cool idea. These wavy magnetic movements, the torsional oscillations, disrupt the slow currents inside Jupiter, messing up the cloud patterns and causing wild weather. And when the scientists calculated the time it takes for these wave-like motions to happen, they discovered that they match the same time periods when the stripes on Jupiter change. So, in simple terms, the scientists think that these wave-like movements in Jupiter's magnetic field are causing the changes in the stripes on the planet. Pieces of a puzzle are coming together. Scientists are still trying to fully understand why this happens, but it's an exciting step forward in unraveling the mysteries of our vast universe. But there are still some mysteries left to solve. To find more answers, scientists need to keep watching Jupiter closely in the future. By observing how the clouds change, they can check if their theory is correct or if it needs some adjustments. From its massive storms to its colorful belts, Jupiter never fails to amaze us with its cosmic wonders. It may not have ignited as a star, but it shines brightly as a gas giant, captivating us with its size and beauty. So keep your curiosity alive and always reach for the stars.
Hop on board. Hurry, we don't have much time. We're on a cosmic journey to find the biggest star in the universe. The first star we pass is our own sun. By far, not the biggest one out there, but it's still massive. You could fit 1 million Earths inside it. That means, if you think of the sun like a basketball, Earth would be half the size of a pencil eraser. If we put all the planets on one side of a scale and the sun on the other, the planets wouldn't stand a chance. The sun makes up 99.9% of all the mass in the entire solar system. Mass is basically how much stuff or matter something is made from, and it's what you can thank for stars shining. You see, the more matter in a star, the thicker and hotter its core becomes. This starts a chain of chemical reactions. Hydrogen atoms get smashed into each other to form helium, releasing an incredible amount of energy. That's the star's light and heat. So, bigger stars also equal brighter ones. But with all those reactions going on, this shortens a star's lifespan. When it starts to run out of fuel, the star will enter the giant phase. It'll expand and turn red. Which brings us back to the task at hand. The biggest star we'll find is likely to be on the edge of its life. Switching on our hyper light engines, we soon arrive at the Lumen 16 system. Here, we'll find one of the smallest stars out there, a brown dwarf. Small here means about the size of Jupiter, but they're small for stars. Brown dwarfs are also called failed stars because they don't have enough mass for those chemical reactions. That means they're not as bright, but they're super dense. All the matter in them is packed together so tightly, they weigh 80 times more than Jupiter, even being the same size. And if you think that's something, just look at a white dwarf, even more tightly packed. This one here is Sirius B. It's also about the size of Jupiter, but it'd weigh as much as the Sun. It emits a dim white light. Once it runs out of gas, it'll turn red and cool down. Now let's fly closer to its giant neighbor, Sirius A. You easily see this star from Earth. No telescope needed. Twice heavier and more than 1.5 times wider than our Sun. It's the brightest star in our night sky. Now we fly 550 light-years away from Earth to the constellation Cassiopeia. Almost 100 years ago, a cosmic explosion happened here. It expanded the atmosphere of the star Gamma Cassiopeia, and some gases were thrown into space. After that, it became the brightest star in the constellation. It's 10 times wider than our Sun. On to the famous North Star. Funny enough, different stars have had this title over the years, and more will take it in the future. That's because Earth's pole star changes every 26,000 years. Imagine our planet like a spinning top. The northern pole will shift around in a little circle, pointing at different stars to the true north. The current one is a supergiant 37 times wider and 5 times heavier than our Sun. It's easy to find in the night sky. It's on the very tip of the Little Dipper's handle. Get ready now. We're setting off for the eye of the storm, the center of our Milky Way galaxy. To see the next star, we need to switch to infrared mode. This pistol star is hiding from us in space dust. In just 20 seconds, it emits as much light as our home star does in an entire year. And its size is jaw-dropping. It's 420 times wider than the Sun. But it's still not the most luminous star known to humanity. That would be a blue supergiant in the constellation Triangulum. Meet B416. It's almost 10 million times brighter than the Sun. But the brighter a star, the faster it burns up all its fuel, and the shorter its life. Compared with a red dwarf that barely glows and burns fuel much more slowly, its life will be hundreds of thousands of times shorter. 3,400 light-years from Earth, there's one of the rarest celestial bodies in the universe. It's a yellow hypergiant called Rho Cassiopeia. Among the countless stars in our galaxy, there are only a couple dozen of these. And even though this star is extremely far away from our planet, you can still see it in the sky without needing a telescope. That's because it's 300,000 times brighter than our Sun. It also helps that the thing is 900 times wider than our home star, too. And its color tells us that its fuel reserves will last for a long time. When Rho Cassiopeia starts to turn red and expand, it'll be one of the biggest stars in the entire universe. Now, we move to the constellation Orion. The star is in our sights. Betelgeuse, one of the largest ones visible to the unaided eye. 700 times the size of our Sun. If it took our star's place, its surface would touch the asteroid belt. That's between the orbits of Jupiter and Mars. It would engulf the 4 inner planets, Earth included. But this star has astronomers very excited. They predict Betelgeuse will explode in a fantastic celestial show in the next 10,000 years. It'll be the greatest astronomical event of all time, because we'll be able to observe a supernova at a close but safe enough distance. The exploding star will shine as bright as a half moon. It'll be visible in the daytime sky for a year and at night for several more. Now we venture to stars that exceed the Sun's width 1,000 times. Mu Cephei is a hypergiant boasting the title of the reddest known star. Its color tells us that the fuel gauge is getting closer and closer to empty, but it's still so big that it could hold 1 billion suns in it. And because of its mass, this star will eventually become a supernova or even a black hole. Let's take a trip of almost 4,000 light years from home. Here it is, a red supergiant called VY Canis Majoris. It's one of the biggest and brightest stars of the Milky Way. It could fit 3 billion suns. And even though it's so huge, this thing is surprisingly light, only 17 weights of the Sun. In the context of celestial bodies, you could call this star an inflated balloon. In the next 100,000 years, VY Canis Majoris will explode in a hypernova. Gamma radiation will destroy all life in the local part of the universe. But this star is so far from our solar system that it wouldn't mean any harm to us. If we placed MY Cephei in the center of our solar system, it would bulge all the way out to Saturn's orbit. To remind you just how far away Saturn is, think of it this way. It takes the Sun's light 8 minutes to reach Earth. To get to Saturn, it takes well over an hour. Compared to this massive star, the Sun is just a grain of sand. It's one of the most luminous and reddest stars in our universe. The bigger and redder the star, the closer it is to its end. So, we're not looking at just a titan of the universe, but also one of the oldest celestial bodies out there. The second biggest star in the universe is UY Scuti. It's about 1.5 billion miles wide, 16 times the distance from the Earth to the Sun. This is a pulsating variable star. Its brightness changes about every 2 years. UY Scuti is a record breaker in fuel combustion per year. Scientists expect it to evolve back to hotter temperatures like a yellow giant. Our journey is coming to an end. Before us, we behold Stephenson 218. It takes 20,000 years for light from this star to reach Earth. It's hard not to see this red supergiant on our tiny terrestrial home. It's 2,150 times wider than our Sun. We'd need 10 billion suns to fill its volume. For comparison, the average beach contains only about 5 billion grains of sand.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our Sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part. They're considered the basic building blocks for life. Imagine that. Life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.
Betelgeuse, one of the biggest and brightest stars we've ever seen. It's both gorgeous and dangerous in a way you can't even imagine. This star is old, bloated, and unstable, like me. It can go supernova at any moment. And it hides a mystery our astronomers haven't managed to crack yet. Will it impact the future of our planet? Well, let's see. Betelgeuse is the bright red shoulder of Orion, the hunter in the sky. It's a red supergiant star, and by supergiant, I mean really giant. This star weighs somewhere between 15 and 20 suns, but it's so stretched out that if you dropped it in our solar system, it would reach all the way to Mars. Imagine our planet swallowed by a glowing, bloated ball of reddish fire. No thanks. As for the whole red giant thing, it means a star near the end of its life. When it runs out of hydrogen in its core, it starts burning hydrogen in a shell around it. This makes the star's outer layers puff up and cool down, so it looks much bigger, cooler, and red in color. Betelgeuse isn't exactly in peak health. Massive stars like this live fast and pass away while still young. Their lifetime depend on a lot of factors: mass, spin, how much metal they've cooked up in their cores. But even on the generous side, they only last a few million years. On the tight side, maybe a few 100,000. For comparison, our 4.6 billion-year-old sun has plenty of life left. And tiny red dwarfs can keep going for trillions of years. Trillions! The universe itself isn't even old enough for red dwarfs to start kicking the bucket. Betelgeuse has already burned through all of its hydrogen, and now it's running on helium. That's what made it swell up into a red giant in the first place. Back in 2019, the star suddenly dimmed so much it looked like it was about to explode. Astronomers around the world were super excited. They thought we were about to witness a supernova in real time. But the truth was far less dramatic. Betelgeuse didn't reach the end of its cosmic life. It had just coughed up giant clouds of dust and gas. which drifted in front of it and blocked the light. Later, astronomers seemed to figure out the reason for this thing. The star basically blew off a huge chunk of its own atmosphere into space, and it was massive. The chunk had several times the mass of our Moon, and that's about 400 billion times more material than our Sun throws out in one of its normal eruptions. Once that piece cooled down, it turned into a giant dust cloud. From Earth, that cloud blocked a lot of Betelgeuse's light, making it look like the star was fading. But that's not all. Betelgeuse usually has a steady rhythm. It gets brighter and dimmer every 400 days, almost like a heartbeat. After this outburst, that cycle seems to have stopped, or at least gone quiet for now. When a star is old and unstable, its life might become pure chaos. One moment it's burning hydrogen, the next helium. Sometimes it shuts down. The next day it roars back to life. Its outer layers are so stretched out that they almost seem to be independent and have a mind of their own. Plus, there are terrible secrets these stars can hide, and Betelgeuse has one of its own. For decades, astronomers suspected Betelgeuse might have a hidden companion star, but spotting it was nearly impossible. Why? Because Betelgeuse shines up to 14,000 times brighter than our Sun. Its glow basically drowns out anything nearby. On top of that, our planet's thick atmosphere makes stargazing tricky. Light from space gets blurred and distorted as it fights its way through the air. When the Great Dimming happened in 2019, the Hubble Space Telescope was able to watch it unfold from above the Earth's atmosphere. It managed to clear up fears that Betelgeuse was about to explode, but even Hubble couldn't see through the massive cloud of gas and dust the star had coughed out to check for a potential companion. That's when astrophysicist Steve Howell from NASA's Ames Research Center tried a different approach. He turned to the Gemini North Telescope on Mauna Kea in Hawaii. It's a massive ground-based observatory with a wide opening that lets in more light. Gemini's secret weapon is a high-resolution camera called the Alopiki Speckle Imager. Instead of taking one long exposure shot, it fires off thousands of ultra-short ones. It helps freeze the chaos caused by Earth's atmosphere. Later, computers stitch all those snapshots together, scrubbing away the turbulence and leaving behind crystal-clear images. So, Steve Howell and his team got down to work, convinced something had to be there, something that had slipped through all the earlier searches. With the Alopiki camera, they finally had the tool sharp enough to catch it, if it really existed. Howell later admitted the odds were slim. And still, Howell's team finally caught what looks like a faint companion star hiding at the far edge of Betelgeuse's atmosphere. And the best part was that it showed up exactly where earlier astronomers had predicted it might be. Same spot, same distance, and even the same angle. It wasn't just a random flicker of light. It matched the map. Right now, the companion is still hiding too close to Betelgeuse's blinding glare to see clearly. But its orbit will eventually carry it farther out, away from the giant star's brightness. That moment will come in November 2027, and when it does, telescopes should finally get a clean look. Those follow-up observations will settle the question for good. Is this faint little star real, or just a data glitch? Oh, by the way, the companion star already has a name. Betelgeuse comes from Arabic and means the hand of Al-Jaza, a legendary figure drawn across the night sky by ancient stargazers. They saw her whole form, hands, feet, head, hair, all stitched together by the stars of Orion. So Howell thought it only fitting to continue the theme. He named the companion Sawara, which translates to her bracelet. One day, long into the future, Betelgeuse and Sawara will spiral together and merge. But with a companion star or not, Betelgeuse is old, tired, and basically running out of gas. The clock is ticking, and one day, sooner or later, it'll go supernova. And when it does, it'll be a cosmic fireworks show unlike anything we've ever seen. Based on what we know, its size, how fast it spins, the group of stars it was born with, and the metals in its atmosphere, astronomers guess that Betelgeuse could explode as a supernova in a few 100,000 years. But don't get too comfortable, it could happen tomorrow. Or maybe it already did. Remember, the star is 500 light-years away. That means the light we're seeing now left Betelgeuse many, many years ago. If it exploded a century ago, we wouldn't know it yet. The star might already be gone. But when we finally see it go supernova, it'll be a show like nothing else in human history. A supernova can outshine entire galaxies, and at this distance, Betelgeuse will be blinding. It could be visible even during the day, brighter than any planet and nearly as bright as the full moon. But unlike the full moon, it won't be a comfortable glowing disk. Betelgeuse will remain a tiny pinpoint in the sky, but staring at it might actually hurt your eyes. This brilliance will last for a few months before fading, as all supernovae do. And don't worry, it won't hurt us. Why? Well, as crazy as a supernova is, stars are really far apart. That's where the inverse square law comes in. The energy a star or supernova emits spreads out over space. Double the distance, and the energy per spot drops to a quarter. 10 times the distance, and you're only getting 1/100th of the energy. It's the same reason you can walk a few steps back from a campfire and go from roasting to freezing in seconds. Anyway, what happens next is out of our hands. Maybe Betelgeuse will keep wobbling along for thousands of years, or maybe tomorrow night it'll light up the sky like never before. Either way, the universe has a way of surprising us, and the future will show what this giant star has in store. So this year, before September, a star in the constellation of Corona Borealis will explode, and in the northern hemisphere, we'll be able to see it with the unaided eye. This star is T Corona Borealis, a white dwarf star 3,000 light-years away from our solar system. It will turn into a nova, which we'll discuss a bit later, in spring or summer. Even though this occurrence is predictable, happening every 80 years, it's still a once-in-a-lifetime event, if you're human. T Corona Borealis is not your regular star. It's actually a binary, two stars orbiting each other. This pair, though, is incredibly special. Occasionally, the stars increase their brightness to such an extent that they become visible on Earth. The white dwarf star is the more massive one of the two. But the most shocking thing about it is that it might pack the same mass as the Sun into a volume only as large as Earth. The companion star, an aging red giant, has already expanded so much that it's dumping its material onto the white dwarf. So it's time for another explosion for these two. It's going to take the star's brightness from magnitude 11 to magnitude 2. You see, in astronomy, magnitude is used to measure the brightness of a star or another celestial object. The brighter it is, the lower the number assigned as a magnitude is. It's like golf, low scores, you know. In our case, it means that we'll be able to see the star with the unaided eye, even in light-polluted skies. Now, we can only see the binary with binoculars in a completely dark sky. After the outburst, T Corona Borealis will remain the brightest star in the constellation of Corona Borealis for a few days before gradually dimming. Now, this event shouldn't be confused with a supernova. In a supernova, a star's core collapses, which leads to its complete destruction. It can only happen to a star 8 times the mass of the Sun. Instead of disappearing in a blinding flash of light forever, T Corona Borealis will experience a nova, an explosion on its surface, flinging matter into space but not ruining the star itself. Such recurrent novas happen at regular intervals. T Corona Borealis was known to astronomers from the past as the Blaze Star. Last time it exploded in 1866 and 1946. Astronomers from NASA believe it's going to do it again before September this year. The constellation of Corona Borealis, also known as the Northern Crown, is one of the most beautiful out there. It's a curved semicircle of 7 stars, which is easy to find in April. You should go outside 2 hours after dark and look to the east-northeast. Once you find the Big Dipper, use the curve of its handle to go to Arcturus, finding the bright star in the Buddhist constellation due east. If you go diagonally down to the east-northeast horizon, you'll spot Corona Borealis. Now, if you want to observe the brightening of T Corona Borealis, it might be better if you get acquainted with the region and the stars of the constellation it's in. Once the event begins, you'll be able to compare its brightness against the other stars and observe the thing without using any fancy cameras. Now, a nova is a short-lived sudden explosion involving a compact star as large as Earth or a bit bigger. The outburst comes from a white dwarf circling remarkably close to a regular star, so close that a stream of gas flows between them. This gas starts piling up until it creates a layer on the white dwarf's surface, and then it reaches a point where it detonates in a runaway thermonuclear explosion. According to astronomers, around 50 nova happen every year in our galaxy, but not all of them are noticed. NASA's Fermi Gamma Ray Space Telescope has observed several nova that occurred not far on the scale of the universe. They found out that each blast produces gamma rays. Those are the most energetic forms of light. Researchers also think that these gamma rays result from collisions among numerous shock waves, racing from the explosion site in a quickly expanding shell of debris. Now, after we've talked about novae, it's time to discuss something much more dramatic: supernovae. It's the largest explosion humans have ever seen. Each blast is a super powerful burst of a star. One kind of supernova is caused by the last hurrah of an extinguishing massive star. It happens to stars at least 5 times the mass of our Sun. Once they near the end of their lives, they go out with a ginormous bang. Huge stars burn incredible amounts of nuclear fuel at their core, producing tons of energy. It makes their centers immensely hot. Heat generates pressure, and this pressure keeps such stars from collapsing. But any star is in balance between two opposite forces. Its gravity attempts to squeeze the star into a teeny tiny ball, and the nuclear fuel burning at the core of the star produces powerful outward pressure. Now, when a giant star is running out of fuel, it starts cooling off. Its pressure drops and gravity wins. The star collapses. An enormous object that is millions of times the mass of Earth collapses within 15 seconds. No wonder this brisk process produces enormous shock waves. It makes the outer layers of the star explode. Eventually, an incredibly dense core is all that is left behind, besides a growing cloud of hot gas called a nebula. A black hole, the densest object in the universe, is the result of a supernova of a star around 10 times as massive as our Sun. Also, there's another type of supernova. It usually happens in systems where 2 stars orbit each other, and at least one of these stars is a white dwarf the size of our planet. If such a star collides with another, or pulls too much matter from its neighbor, it can explode into a supernova. Also, supernovae are often so bright they can outshine the combined light of entire galaxies for several days or even months. Supernovae aren't common. Astronomers think just a few of them occur within the century in galaxies like our home Milky Way. But since the universe contains an enormous number of galaxies, we can observe a few hundred supernovae every year outside our galaxy. Unfortunately, space dust blocks our view of most supernovae happening within the Milky Way. Betelgeuse, a late-stage red giant, exploded in 2019, but it wasn't the event we expected to see. This star is found in the constellation of Orion and is huge, so big that if we moved it to the center of our solar system, its outer edge would go way beyond the orbit of Jupiter. When Betelgeuse eventually nears its end, it will explode in a stunningly bright supernova visible on Earth even during the day. This explosion could happen as soon as tomorrow or as far-flung as hundreds of thousands of years from now, so don't hold your breath. But then, what was it in 2019? Astronomers noticed that the star was dimming. They decided it was the initial stages of the grand show. But instead, Betelgeuse went back to normal over the course of the next few months. Further analysis revealed that the star hadn't dimmed. It just looked like that because we had been observing it through a cloud of stellar debris. At the same time, the amount of light in the photosphere of Betelgeuse ramped up. It was like a massive explosion of material from the surface of the star. Events like this occur on the Sun all the time, especially when our star's activity is high. Bits of the Sun's surface get tangled up and cast off. That's what we call coronal mass ejections. They don't harm our planet, but they can mess with satellites and electrical equipment. Now, getting back to Betelgeuse, we've never seen such a huge mass ejection on the surface of a star before. It's a new phenomenon which we can observe directly and even see surface details with the help of the Hubble telescope. Astronomers say we're watching stellar evolution as it happens for the first time.
At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. Only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard Worlds Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across 2 black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri e, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, the year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri e had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Cancri e might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Cancri e, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pole star, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pole star in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where 2 massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets like Korot 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tres 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve as a reminder of how much we have yet to learn about the universe.
The Earth, frozen and alone, exiled into deep space. Jupiter, the only remaining planet orbiting the Sun. No, it's not a premise for a disaster movie. It's one of many real scenarios scientists explored in their latest simulations. This time, the threat isn't the Sun swelling or a giant asteroid knocking planets into it like a cosmic bowling ball. It's something quieter and possibly already on its way. A recent study examined the potential consequences of a passing star coming too close. One such flyby could send planets crashing, flinging them into space, or mess with their orbits just enough to cause climate changes. But what are passing stars, and how likely is that to occur? Passing stars are normal stars, like our Sun, that move around the Milky Way. Since everything in space is always moving, sometimes stars pass near each other. Usually it's not a big deal. But if a star gets really close, its gravity can tug on planets like Neptune. That tiny tug can slowly change how the planets move, like a ripple spreading through the whole system. Scientists study these close encounters because, even though they don't happen often, they can have big effects over millions of years. They help us understand shifts in planetary orbits and how they may have shaped Earth's past. In fact, one theory suggests that a flyby 56 million years ago is what caused great climate change when Earth's temperature rose by up to 14 degrees Fahrenheit in just a few 100,000 years. That huge temperature jump changed life on Earth, leading to the evolution of some species while causing others to disappear. Even though it's impossible to prove whether there was a flyby a long time ago, we do know that events like this could mess with Earth's orbit in the long run. That's in the past, but what about the future? So far, we know that the solar system will have a close encounter with another star called Gliese 710 in about 1.3 million years. Gliese is moving towards us and is projected to pass within 10,000 astronomical units of the Sun. It won't come close enough to throw planets off, but it could still send icy comets from the Oort cloud our way, like a bored kid tossing a snowball without looking. One might hit something, but probably won't. However, in a recent study, scientists wanted to explore a more extreme scenario. What if a star passed even closer, say just 100 astronomical units from the Sun? That's about 100 times the distance from Earth to the Sun. From our point of view, it's almost unimaginably far, but in space, it's practically brushing shoulders. They ran thousands of long-term simulations covering up to 5 billion years of our solar system's future, and it turns out it doesn't take much. Just one close encounter can be enough to disturb the outer planets, like Neptune, and set off a slow-motion chain reaction that ripples inward. Over time, that gentle nudge can throw the whole system into chaos, a true cosmic butterfly effect. The good news is that even in this worst-case scenario, in 95% of simulations, the passage is nothing to worry about, and all the planets remain in place. However, in the remaining 5%, well, it's one disaster after another. The most frequent casualty in these simulations was Mercury. In nearly half of all unstable scenarios, Mercury ends up on a doomed path straight into the Sun. It's the smallest planet and the closest to our star, so it's especially susceptible to gravitational nudges, whether from the gas giants or from a disturbance rippling inward from a stellar flyby. When Mercury spirals into the Sun, you might think it's game over for the rest of the planets, but that's not always the case. Sometimes the system absorbs the loss and restabilizes, like an orchestra that keeps playing even after one violinist falls off the stage. Oops. Funny enough, Mercury already has a chaotic orbit, the most stretched and tilted of all major planets. and some studies already consider its fall into the Sun in the distant future inevitable. Now, Venus has a slightly better chance in these chaotic scenarios. It doesn't get ejected or swallowed by the Sun as often as Mercury, but it's far from being safe. Most of the time, the instability happens after Mercury goes rogue and disrupts Venus's orbit, nudging it into a slow-motion crash course with Earth or Mars. Even without the interference from field stars, long-term simulations show a tiny but real chance that Venus could eventually collide with Earth just from the way Jupiter affects Mercury. A Venus-Earth collision would result in both planets being completely destroyed. Oh well. A similar fate awaits Mars. According to simulations, in about 0.3% of cases, it either gets flung out of the solar system or collides with another planet. Mars is smaller and lighter than Earth, with weaker gravity, which makes it easier to knock it off track. What's interesting is that even in some cases where Mars is lost, Earth often manages to stay in place. Jupiter happens to be the heavyweight champion of the solar system, the proud owner of its own cloudy belts. Thanks to its massive size and strong gravity, it acts like an anchor, keeping everything else in check. There are 392 scenarios out of 12,000 simulations where all but one planet vanished, with Jupiter being the last one standing. Its stabilizing influence helps prevent smaller planets from going off course, and in some cases, it even helps the system recover after a disruption. Saturn, while less massive, seems to be Jupiter's loyal partner. But models show that when Saturn shifts its orbit abruptly, it can send gravitational ripples, known as secular resonances, straight into the inner solar system, nudging the orbits of planets like Earth and Mars. Finally, the most vulnerable ones are Uranus and Neptune. Sitting at the edge of the solar system, they're the easiest to knock loose, and in many simulations, they get ejected entirely. That loss sends gravitational ripples inward, disturbing the rest of the planets over millions of years. Even a tiny shift by 0.1% in Neptune's orbital distance can throw the whole solar system out of sync. The balance of gravitational forces would shift, forcing Jupiter and Saturn to readjust, which would push the disturbance toward the inner planets, destabilizing everything. Which brings us to the big question: what about Earth? While most simulated models leave Earth untouched, about 0.2% of the simulations end with Earth either colliding with another planet, Venus, or being thrown into the Sun. Out of 12,000 simulations, in 23 of those, Earth ends up as the only one still orbiting. But that's only if we don't include the Moon in calculations. With the Moon included, Earth becomes harder to predict. Our satellite could crash into Earth, get ripped away by a passing star, or destabilize our orbit over millions of years. Once again, this is a worst-case scenario, and while the odds are really, really small, it's not impossible. So, with that in mind, let's entertain the idea and see what would happen to Earth if it were to end up exiled from the solar system. Earth would become what scientists call a rogue planet, drifting through interstellar space with no sun to anchor it. The surface would quickly freeze, with temperatures dropping to hundreds of degrees below zero. But surprisingly, life wouldn't vanish completely. Earth's core would stay hot for billions of years, powered by radioactive decay and leftover heat from its formation. That heat could keep underground pockets warm. Scientists believe that this is the case with icy moons like Europa or Enceladus. Life might cling on in different caves or buried oceans. It wouldn't be a thriving world, but it wouldn't be completely empty either, at least for a while. Just cold, quiet, and alone. A ghost of a once lively world. And somewhere out there, maybe another civilization will look up, spot a faint blue dot drifting by, and curiously start running simulations of what might happen if this blue planet were to get really close, say just 100 AU from their sun. Scientists have found an invisible star at the Milky Way center, a star that helped our galaxy be born. 26,000 light-years away, in the galactic center, a massive, invisible object started spreading everywhere, and you don't even know that you're breathing it right now. It all started in the 70s when an astronomer named Vera Rubin was studying the Andromeda Galaxy. She decided to check whether stars move in a predictable way. Now let's say you're spinning a ball on a string around yourself. The closer the ball is to you, the faster it moves in a tight circle. But if you let the string out longer, the ball moves more slowly in a bigger loop. That's how gravity works. And the same goes for planets. The closer ones, like Mercury, zoom around quickly, completing their orbits in months. The far ones, like Neptune and Saturn, take their time, decades, to make one rotation. The stars themselves should orbit the centers of their galaxies the same way. The closer ones move fast, the farther ones are slower, right? But when Vera measured the speeds, she saw something impossible. They weren't slowing down. The faraway stars were moving just as fast as the ones near the center. By all logic, the galaxies should have torn themselves apart, but they didn't. And that meant something was holding them together, something undetectable, some massive invisible object in the galactic center warping reality without ever revealing itself. So she checked over and over with different galaxies. This wasn't a fluke, it was happening everywhere. Rubin had accidentally uncovered proof that galaxies were drowning in something far heavier than all the stars, planets, and gas in our entire universe combined. It was holding us with ghostly hands. Astronomers called it dark matter because it doesn't glow, doesn't reflect light, doesn't seem to interact with anything at all. It's just there. But all the calculations show us that it exists, and not merely exists, but makes up 85% of all the mass in the universe. We know that it sculpted galaxies. Without it, the world as we know it wouldn't exist. And yet, just like with an invisible star scientists found at the Milky Way center, the only way to detect it was through gravity. So how do you find something that refuses to be found? Recently, scientists discovered there might be an invisible star at the Milky Way's center, and this fascinating discovery might finally help us understand what dark matter looks like. They began looking for dark matter's fingerprints, any signs of its presence anywhere. They studied how galaxies moved and smashed particles together in giant machines, hoping to create tiny bits of dark matter in the lab. This didn't really lead to anything. They didn't even know what to look for. Is dark matter even made of particles? There was a theory that suggested that it's made of ghostly particles that barely touch anything, or even weirder ones that might flicker in and out of existence in the blink of an eye. There was a problem, though. If dark matter really worked like that, then the centers of galaxies should be packed tight. Tons of matter would be crammed into a tiny space. But in our universe, galactic cores seem strangely soft, spread out, almost gentle. A new theory emerged, and it was wild. What if the dark matter at the heart of galaxies isn't made of heavy particles at all? What if it's made of something so delicate that it behaves more like a strand of hair? These hairs could be made of something incredibly light, lighter than anything we've ever seen, and billions of times smaller than a neutrino, which is already the lightest known particle. They called this idea fuzzy dark matter, and it might change everything we thought we knew about the universe. A team of astrophysicists wanted to test this idea, so they ran a simulation, creating a simple model of a galaxy with two main ingredients: a whole lot of fuzzy dark matter and a little bit of gas, the same kind of gas that forms the stars we can see. They pressed start and just let the system evolve by itself, watching how the two would interact. At first, everything was pure chaos, but then the fuzzy dark matter started to gather. It pulled itself together, forming a massive invisible object near a galactic center. The gas followed, spreading throughout this ghostly mass, mixing with it and glowing faintly. And then, it suddenly formed something incredible: dark stars. Not typical stars like our sun, blazing with heat and light. Instead, it's enormous, massive, invisible objects, a hybrid of two different kinds of matter. We've never seen anything like this before. An object that would stretch across thousands of light years, and yet they'd be almost weightless. more like cosmic puffy clouds than anything else. Scientists called them fermion boson stars. Finally, this dark matter thing is starting to make sense. The core of this strange invisible star would have just the right density, not too dense, not too loose, and it looked exactly like what astronomers actually see in real galaxies. If it's confirmed, then it would finally explain how dark matter behaves and works. And if they're right, then every galaxy in the universe could be tied to one of those vast unseen giants. The Milky Way hidden star might be one of them, shaping our galaxy in ways we never realized. What's wild is that this stuff wouldn't behave like normal matter. It wouldn't form anything solid. Instead, it would be more like a complex, ever-moving web of filaments or hairs. This also means that Earth might be completely surrounded by it. Dark matter still follows the rules of gravity. As it moves past planets and stars, gravity pulls it into focused streams, so it's both hugging and passing through our planet, wobbling consistently. If we could see them, they might look like glowing invisible threads everywhere, and they'd pierce right through the planet, stretching far into space. But this is only the beginning. Now scientists need to refine their models, make them even more detailed, and compare their predictions to real galaxies. But this dark star discovery in the galaxy's center isn't our only clue. Luckily, the universe has given us a way to look for that fingerprint: gravitational lensing. When light from a faraway galaxy travels toward us, it sometimes passes by another massive galaxy on the way, or other massive objects with crazy gravity. Instead of continuing in a straight stream, light actually gets bent around the massive object because of that gravity. And when it finally reaches us, it creates a distorted and magnified version of the original galaxy. Basically, it's like looking through a piece of curved glass. If dark matter is fuzzy, then it should leave a strange pattern on these distorted images. Things should be a bit wavy and unclear. Scientists needed the perfect object to study this, and they found one. A faraway galaxy whose light was bent by gravity, creating a strange stretched-out image. They used super powerful radio telescopes, connected them all over the world, and turned them into one giant telescope as big as the Earth itself. With this, they could zoom in so much that they could see details of that galaxy as tiny as a grain of sand on the moon. Then they ran a huge experiment. They created their own fake versions of this picture, simulations with various sizes of fuzzy dark matter particles. And at a certain point, they found the perfect match. This helped us calculate the exact mass of dark matter particles before we even detected them. And the clues are leading us right to our own galaxy. It seems like densest parts of these hairs, the roots, might be super close in the cosmic scale, just tens of thousands of miles from Earth. That's close enough for a space probe to reach. Now that scientists have found this invisible star at the Milky Way center, we just need to study it up close, send a mission to one of these roots, and then we might finally crack the greatest space mystery of all.